चलो,
Done, sir.
yeah. So we'll start with a new topic, which is refraction of light. Keep reading. Refraction of light. So we studied reflection. Now we are going to study refraction of light. Tell me, what is refraction of light? The meaning क्या है? Refraction means what? Refraction phenomenon means? Yeah, tell anybody.
So the bending of light when it passes when it passes from one medium to
The
another.
other medium. Okay. So whenever till now, what I in air may if I put a torchlight, only one medium is there, it is going straight. Suppose air and water is there, bottom में water is there, air is there. I put a torchlight, air तक सीधा जाएगा, बाद में some bending will take place in water में. Okay, that bending phenomenon को we call as refraction of light. Okay, so write down. Bending of light when it passes from one medium to another medium is called as refraction of light. Okay, why it is bending then? Bending हो रहा है, okay, ठीक है. Why is bending when it passes from one medium to other medium?
The density.
Speed of light changes.
Speed of light वाला, okay, change हो रहा है. Air में अलग speed है, suddenly water में अलग speed है. So because of that, these are, see, one of the example, pencil आप घर में भी कर सकते हैं. You put a pencil, you feel it is broken. If you see in a side view में ऐसे देखे ऐसे, like top view से देखे ऐसे देखेंगे तो you'll feel that it is a broken. This is a phenomenon where we call this refraction बोल के. Okay, so देखो, refraction is caused due to change in speed of light as it passes through different materials with different refractive indexes. A refractive index क्या है? You will understand आगे. Right on. Because of change in speed of light as it passes through different materials with different refractive index. हो गया? ओके, आपको, हाँ, चलो एक देखो एग्जांपल, आपको पेन क्यों ब्रेक होगा बोल के आपको समझ में आएगा. देखो, पेंसिल, दिस इज द एक्चुअल पोजीशन ऑफ द पेंसिल यू प्लेस्ड एंड यू आर सीइंग फ्रॉम द टॉप व्यू, यू आर सीइंग फ्रॉम द ऐसा साइड में देख रहे हो. ओके, सो आपको क्या लगेगा, आपको लाइट, देखो कभी भी ऑब्जेक्ट से रेस विल बी कमिंग, राइट? See, then only we can able to see, right? Objects say rays will be coming and entering to our eye, then only we can able to see. Okay, so objects say rays are coming, and when it is entering to other medium, it bends, right? Bending phenomenon is like this. So bend करके आंख में जा रहे हैं, we feel that the rays are coming from here. That means the pencil इधर है बोल के आपको लगेगा. That's why आपको breaking phenomenon जैसा आपको दिखेगा. समझ में आया? See, objects say rays will be coming, then only we can able to see our eye, to our eye में जाएगा, then only we can see, right? Every object. अभी पेन क्यों दिखेगा बोलते हो, इधर से rays आ रहे to our eye, then only I can see this. If there is no light, I cannot see the rays, I cannot see this object. I say, this pencil is the actual position of the pencil. Okay, rays are coming from this pencil and reaching to our eye, but before reaching, it is entering to other medium, like water to air is ending. So bend हो रहे हैं, वो bend करके आपको eye में जा रहे हैं. हम लोग का लगेगा कि the rays are coming from this object, because we will feel always the rays को extend कर रहेगा ना, like extend किया तो we will feel that the rays are coming from here, we will feel that the object is here, that's why it is broken जैसा लगेगा आपको. Okay, समझ में आ रहा है? अनुष्ठा चला. Okay. Now, till now, I understood that refraction is a bending phenomenon. Okay. So when I suppose I take air and glass medium, when a ray of light incident like this, when it entering, it bends. Bending में either towards normal or away from normal होगा. We will see आगे when it's towards, when it's आगे. Bending तो होगा ही होगा compulsory. If there is a change in medium, bending will take place either towards normal or away from normal. We will see आगे when it is that. Okay, this is called incident ray. This is called refracted ray, and this is the angle of incidence, angle of refraction. Okay, ये draw करो.
So rough diagram or like
Yeah, normal draw करो. Rough diagram ले. So bending phenomenon is taking place in every interface. This is called interface. The boundary बोलते हैं or interface बोलते हैं. It is separating the two different mediums. That is called boundary. Okay. Okay. Now we will study about the laws of refraction. Which same thing. Reflection में कैसे पढ़ा? Refraction also same way will go. Okay. Refraction में laws of refraction. Okay. Copied. Yeah. Laws of refraction. So, you know, laws, right? First law of reflection में. What is the first law of reflection में? Reflection में.
Difference is equal to angle of reflection.
First one we studied about incident ray, normal, reflected ray, all lies in the same plane बोल के पढ़ा ना.
But-
Same thing इधर भी रहेगा, but reflected के जगह में refracted ray रहेगा. Okay. So लिखो, the incident ray, refracted ray and normal to the interface of two transparent medium at the point of incidence all lie in the same plane. All lie in the same plane. This is the first law is same for both. Like reflection का में, loss में, ये वाला refracted में, दोनों first law is same. Okay, second law is important. Second law बहुत important है. याद है किसी को second law?
Angle of incidence is equal to angle.
That is reflection में, refracted में.
It's not equal.
No, वो तो हमेशा इक्वल है. किधर भी हो ना, नहीं तो रिफ्लेक्शन वाला आकर मारेगा, अरे मेरा लॉ क्यों रॉन्ग है बोल के. हाँ.
Incident ray is equal to angle of incidence is equal to angle of refraction.
ये एंगल ऑफ इंसिडेंस अभी इसमें एंगल ऑफ इंसिडेंस एंड एंगल ऑफ रिफ्रैक्शन सेम है. बेंडिंग हो रहा है ना, बेंडिंग में क्यों है? 60 डिग्रीज होगा, 45 डिग्रीज होगा, 30 डिग्रीज होगा और 85 डिग्रीज होगा, बट सेम नहीं रहेगा. इन दिस में रिफ्रैक्टेड में नहीं है, रिफ्रैक्टेड में तो नहीं है, बट what is second law says, like very important, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a light of given color. I'll explain this one. And for a given pair of medium. And this law is also called as Snell's law. Very important. I'll explain. So what is saying? The ratio of sine I by sine R is always a constant value. This is the second law. We will see. इसके बारे में देखेंगे. Where I is incident ray, incidence, angle of incidence, and R is angle of refraction. Exam में they will ask define Snell's law. So what the done is, see, when the light is entering from one medium to other medium, it is bending. Olden days में कितना bend हो रहा है? That calculation they want. Scientists want that calculation. Like how much is it? Suppose if I incident the interface में 60 degrees, enter होने के बाद कितना exact angle? After doing experiment नहीं है. Before doing experiment, you have to know how much angle it will bend, and experimentally you should prove. ऐसा रिलेशनशिप है बोल के दे स्टार्टेड डूइंग द एक्सपेरिमेंट्स. Many scientists they use different things, algebra, trigonometry, ये पूरा geometry पूरा लगा के they tried, they done experiments, कितना एंगल क्या रिलेशन है दोनों को, they tried. One of the scientists called Snell's, he has took the help of maths in the trigonometry में आएगा ना sin and cos, 10th में भी रहेगा maths में trigonometry बोल के sin वाला. So यो use करके he found the relationship between angle of incidence and angle of refraction by this relationship. We will see that one. Okay. This constant value उसका नाम दिया है, उसको refractive index बोलते हैं. इस constant को we call as refractive index of the second medium with respect to first medium. So how to represent refractive index? This constant को we call as refractive index. उसको कैसे रिप्रेजेंट करेगा? n to 1. So what is the meaning of refractive index here? How to read this one? Refractive index of second medium with respect to first medium. Always refractive index is a relative term. Always second medium we are comparing with respect to first medium. That is called refractive index. Okay. So n to 1 बोलते हैं. Refractive index of the second medium with respect to first medium. तो रिफ्रैक्शन में लेंसेज स्टार्ट होने से पहले वी आर डूइंग मान्य ऑन द वीडियो, आसिका ऑन द वीडियो. Refractive index of the second medium with respect to first medium. So first law, second law. First law is same only. Second law is nothing but Snell's law. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given color and given pair of medium. Okay. चलो इसका एक्सप्लेनेशन देखेंगे क्या है बोल के बोले से. ओके देखो सपोज मान लो आई एम टेकिंग वन इंटरफेस. Three cases I am taking. Here I am fixing the medium. I am fixing the medium. मान लो air and glass. So medium is fixed. अभी तक pair of medium is fixed and I am doing the experiment in three cases में same medium से I am doing. Okay. Now I am the color also fixed. I am fixing the color also. Okay. So I am incidenting different angles में I1. Different angles में I am incidenting I2, I3. Right? I am doing experiment. Here, what are the things are fixed? Given pair of medium is fixed for three cases में, and the color also fixed for three cases में. Okay. In this में, you already know that it bending phenomenon is taking place. It will bend with different angles or same angles. Angle of incidence is different. Whether it bend with the same angles or different angles. Bolo. Different angles because some 60, 85, some 90 I'm giving different angles. Mein, the bending phenomenon will be different. So, मान लो it is bending R1, some angle it bend R2, and some angle it bend R3. Okay. So, we are doing experiment. Three cases mein color and pair of medium is fixed. I am incidenting different angles mein. I am observing the angle of refraction. I noted down. Okay. And I took a calculator. I am calculating like this. Sine I1 by sine R1. Similarly, sine I2 by sine R2. And similarly, I calculate sine I3 by sine R3. I calculated तीनों cases का this incident angle, refracted angles. Incident angle, refracted angles, I calculated these three cases. Okay. He observed that all are equal. Suppose you got 1/2, here also 1/2, here also 1/2. That means I can write simply in the three cases mein sine I by sine R is constant. The value is constant. This one is Snell's law. Okay. And this constant value he found and he given a name that is called refractive index. I represent that as N2, 1. Meaning क्या है? This is first medium, second medium. Meaning क्या है? Refractive index of second medium with respect to first medium बोलते हैं. So this one is Snell's law. Okay. That means if I know the constant value, if I know the angle of refraction, I can find angle of incidence. Or if I know the constant value, if I know the angle of incidence, I can find angle of refraction. Okay. So he found the relationship between angle of incidence and angle of refraction in refraction concept. Okay. So that is called Snell's law. Now, now you will understand its meaning. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for a light of a given color. The color is fixed. And for a given pair of medium is also fixed. Air and glass are fixed, right? In three cases, in that case, only this relationship holds good. And that's why iska naam hi dene ka, right? Aapka naam nahi dega na. Jo discover kiya ho iska. That's why he has given Snell's law bol ke diya. Okay. And that constant ko we call as refractive index. Iske baare mein detail mein karne wala hai. Refractive index is we represent as N2 1 always. We represent N2 1. Second medium we are comparing with the first medium ka. Okay. चलो ये डायग्राम ड्रॉ कर लो, आपको आगे में समझ में आ जाएगा. जाने में अंडरस्टैंडिंग. या रेगुलर में आ जाओ, डू होमवर्क, सिंसियरली करो. अच्छा लगे 10th क्लास है यार, क्यों परेशान हो रहा है? So after getting the knowledge of refractive index, we can know how much bending is taking place with the help of the refractive index. कितना times bend हो रहा है, we can know. If I get a number, that many times it bending taking place बोल के आपको idea आएगा कितना times bend हो रहा है. Refractive index gives the idea of bending phenomenon. Finished? दोनों जाने? Okay, चलो. Now we'll talk about refractive index क्या. Okay, refractive index definition बोले तो भी Snell's law लिखने का. Snell's law बोलते पूरा नहीं लिखने का. The ratio of sine of angle of incidence to the sine of angle of refraction is called as refractive index. N to 1 का definition is asking. Okay, so refractive index का देखो refractive index is nothing but the ratio of sine of angle of incidence to the sine of angle of refraction is called refractive index. This is the definition always. Okay, देखो when a ray of light that travels obliquely from one transparent medium to another transparent medium will change the direction in the second medium, right? This one, you know, it direction is changing. Okay, the extent of change of direction that takes place in a given pair of medium may be expressed in terms of refractive index. That constant value को we represent. कितना times bend हो रहा है, कैसा bend हो रहा है बोल के we express. Sometimes bits में they will ask this type of thing. Okay, the which variable will decides the the extent the change in direction that takes place in the pair of medium is nothing but refractive index. Okay, and definition to normal है. The ratio of sine of angle of incidence to the sine of angle of refraction is called as refractive index. Copy down. Before starting the lenses, these refractive index concepts are there. उसके बाद lenses start होगा, concave lens, convex lens वगैरह वगैरह. And we represent as N to 1, right? N to 1. Refractive index of second medium with respect to first medium. That formula will be always N2 by N1. This is the formula. मतलब refractive index of the second medium by refractive index of the first medium. That is called N to 1 का meaning. N2 by N1. They'll give each one. See, what is the meaning of this one? Suppose I given refractive index of water is suppose 3/2 दिया suppose दिया ऐसा. What is the meaning of that one? Refractive index of water with respect to air only. Whenever it does not mention other medium, that is nothing but air only. So that's why NWA is nothing but 3/2 value. Okay. Any material if the given refractive index with respect to air is comparing and is telling meaning. Okay. So N to 1 का formula we got as N2 by N1. And this refractive index depends on the speed of the medium. Light speed पर depend होगा. मतलब एयर में जा रहे हैं, वाटर में जा रहे हैं, डिफरेंट रिफ्रैक्टिव इंडेक्स. एयर से डायमंड में जा रहे हैं, डिफरेंट रिफ्रैक्टिव इंडेक्स. some one medium to other medium where it is entering, the medium पर depend होगा ये refractive index का, मतलब speed पर depend हो रहा है. We will see the relation, इसके and speed का क्या relation है, we will see. Copy to live. So we studied only laws of refraction. First law तो normal है, second law तो Snell's law है. Snell's law we explained, and Snell's law से ही आपको एक terminology we got refractive index, उसका representation है n21, n2 by n1 बोलते हैं उसको. Okay. Next. Now I told you refractive index depends on the speed, right? Okay. मान लो v1 is the speed of the medium 1, this is first medium, second medium. We do the picture, right? एक ही ड्रॉ करो, बस पूरा लिखने की जरूरत नहीं है. So the light is entering from one medium to other medium, bending will take place, right? This is I, this is R. मान लो this is air medium, this is glass medium. Okay. इसका refractive index is n1 in the first medium. Glass का refractive index is n2 in the second medium. Okay. And speed of light in the first medium मान लो v1, and speed of light in the second medium is v2. Okay, एक ही diagram draw करने का. Okay. Then we will define the refractive index in terms of speed of light में we will define speeds of light in different medium के हिसाब से we will define the refractive index. So एक ही diagram draw कर लो. This is first medium, medium 1, this is medium 2. In terms of speed of light में we have two types of refractive index का we will talk. Okay. So we have two types of refractive index. First one is a relative refractive index. Relative refractive index means simply the ratio of speed of light in the first medium to the speed of light in the second medium is called as relative refractive index. So this is usually represented by n21. देखो n21 का formula will be, we know this one normally. Formula क्या है? n2 by n1. In terms of speed of the relative refractive index means the ratio of the speed of light in the medium 1 to the speed of light in medium 2. मतलब medium 1 का speed v1 we thought, right? And medium 2 का speed of light is v2. This is called as refractive index, relative refractive index. Okay. So what is the formula we know? n2 by n1 is normal one. In terms of speed of light में first medium speed by second medium speed ratio को we call as relative refractive index. Okay. We are defining refractive index in terms of speed of light. Okay. लिखो. From this you can understand that whether refractive index is directly relation with the speed of light or inverse relation. By formula say you can tell. Here 2 is there, 1 आ रहा है, 1 is there, 2 आ रहा है. मतलब refractive index is directly proportional to speed of light, inversely proportional to speed of light.
Inversely.
Inversely. मतलब you write down this one, very important. Refractive index is inversely proportional to the speed of light. Speed of light in that medium. मतलब एनी मीडियम विच हैज हाई रिफ्रैक्टिव इंडेक्स उसमें स्पीड ऑफ लाइट इज लेस. ओके, सो इसमें इसका मीनिंग क्या है? हायर हाई रिफ्रैक्टिव इंडेक्स, लो स्पीड ऑफ लाइट्स, लो स्पीड ऑफ. ओके, एंड लो रिफ्रैक्टिव इंडेक्स, उस मीडियम में द स्पीड ऑफ लाइट इज हाई, हाई स्पीड. इनवर्स रिलेशन मीनिंग वही है ना, लो है तो हाई, हाई है तो लो. एंड ये हायर रिफ्रैक्टिव इंडेक्स जो मीडियम में हाई रिफ्रैक्टिव इंडेक्स इज देयर, उस मीडियम को वी विल कॉल एज डेंसर मीडियम, डेंसर मीडियम. एंड लो रिफ्रैक्टिव इंडेक्स मीडियम को वी कॉल एज, क्या बोलते हैं इसको? रेयरर मीडियम. आगे भी लिखेंगे वाला डेफिनेशन का, बट अंडरस्टैंड करो, नोट बोल के स्मॉल लिखो. हायर रिफ्रैक्टिव इंडेक्स मीडियम को डेंसर मीडियम बोलते हैं, लोअर रिफ्रैक्टिव इंडेक्स मीडियम को रेयरर मीडियम बोलते हैं. उसमें डेंसर मीडियम में स्पीड ऑफ लाइट इज लो, लेस स्पीड आएगा. ओके, लाइट जब, बिकॉज डेंसर मीडियम में क्या होगा, पार्टिकल्स आर वेरी क्लोजर, उसमें मैं टॉर्च डालूंगा, द स्पीड व्हेन इट्स एंटरिंग इनटू दैट मीडियम इट बिकम्स स्लो, बिकॉज पार्टिकल्स आर वेरी क्लोजर, डेंसिटी ज्यादा है, राइट? दैट्स व्हाई स्पीड बिकम्स लेस. But low refractive index means particles are very far. That time when I put a light, light will be faster in that medium part compared to denser medium say faster. Okay. So in terms of speed of light, we define first type of refractive index, relative refractive index. Okay. Now second one is absolute refractive index. Absolute refractive index. So absolute means the ratio of the speed of light in air. If the first medium is air, that is always absolute refractive index to the speed of light in other medium. Okay, so speed of light in air we represent as c, and speed of light in medium we represent as v. मतलब फर्स्ट मीडियम कभी भी एयर है तो उस टाइप ऑफ रिफ्रैक्टिव इंडेक्स को वी कॉल एज एब्सोल्यूट रिफ्रैक्टिव इंडेक्स. ओके, so final formula you have to understand, this is n21, right? Second medium with respect to first medium. देखो final formula is n21 is equal to n2 by n1, right? That is equal to either v1 by v2. If the first medium is air, instead of v1 we have to put c by second medium ko v. Okay, this is the final formula you have to remember of refractive index. You can solve numericals based on this. Okay, and this type of refractive speed of light in first medium to the speed of light in second medium को क्या बोलते हैं? Relative refractive index. याद है ना वाला? RRI रहेगा. Okay, relative refractive index. And this type of refractive index को we call as absolute refractive index. We studied, right? Absolute and relative refractive index. नो न्यूमेरिकल्स करने समय आपको कैसा लिखने का समझ में आने का. देखो, सपोज इफ आई टेल हाउ टू रिप्रेजेंट रिफ्रैक्टिव इंडेक्स ऑफ वाटर विथ रेस्पेक्ट टू ग्लास, बोलते हाउ टू रिप्रेजेंट, टेल में. रिफ्रैक्टिव इंडेक्स ऑफ वाटर मींस फर्स्ट वाटर लिखो, W लिखो, विथ रेस्पेक्ट टू ग्लास इज NWG बोल के रिप्रेजेंटेशन आपको आने का. ओके, he can ask, suppose see, he will give refractive index of water separately, he give refractive index of glass separately. He will tell to find refractive index of water with respect to glass means W in terms of G लिखने का. That is equal to formula क्या होगा? N21 formula is what? N2 first one जो भी है, जो N2 by second one, right? इधर क्या होगा? NW by NG. दिस रिप्रेजेंटेशन आपको लर्न करना पड़ेगा. ओके, टेल मी हाउ टू रिप्रेजेंट. आद्या बोलो, हाउ टू रिप्रेजेंट refractive index of glass with respect to water. How to represent?
NG by N.
NGW. उसका फॉर्मूला क्या होगा?
NG
N by
NW.
NW. And suppose if they given in terms of speed of light, you can use V1 by V2, and that is equal to, if the first surface is air, you can use C by V. Anything we can use formula. Okay, representation आपको आने का, then only you can calculate. Okay. So when the given refractive index of water is 3 by 2, मतलब meaning क्या है? Refractive index of water with respect to air only. Okay, उसका मतलब N21 is given directly. No need of substituting again N2 by N1 ऐसा नहीं है. N21 is given to you. Now we'll do numericals based on this. Formula क्या है? आ गया? आकाश बोलो, formula is what? Tell me. N21 is equal to?
N2 by N1.
That is equal to, in terms of speed of light में?
V1 by V2.
That is equal to?
C by V.
And V1 by V2 is called as?
Rarer refractive index.
Relative refractive index.
Okay, sir.
And C by V is called as?
Absolute
refractive index.
index.
Shall I understanding that? Okay.
Yes, sir.
Now इसका न्यूमेरिकल्स करने वाले, बट यू अंडरस्टैंड, ये लिखने की जरूरत नहीं है. सी डिफरेंट मटेरियल्स का दे गिवन द रिफ्रैक्टिव इंडेक्स का वैल्यूज. ओके, नो नीड टू मेमोराइज, नो नीड टू डू एनीथिंग, बट आपको एक लर्न करना पड़ेगा. रिफ्रैक्टिव इंडेक्स ऑफ एयर इज हाउ मच? आपको 1 लेने का, ऑलवेज याद रखो. रिफ्रैक्टिव इंडेक्स ऑफ एयर इज 1, because indirectly what we are doing, refractive index of air with respect to air only, right? So air by air is 1, right? So 1 आएगा आपको. Okay, always 1. Now देखो आइस का कितना रिफ्रैक्टिव इंडेक्स है? 1.31. ये बढ़ता जा रहा है. सबसे ज्यादा हाईएस्ट वाला कौन सा है? Which material has highest value? Refractive index is diamond. Very important. डायमंड का वैल्यू बाहर करो 2.42. ओके, सबसे ज्यादा हाईएस्ट रिफ्रैक्टिव इंडेक्स इज डायमंड विच इज 2.42, एंड एयर वाला में 1 है. So based on this you can tell denser and rarer medium, which is denser, which is rarer medium. Tell me air and kerosene, which is rarer, which is denser medium. Tell me. Rarer medium means refractive index is lower. Denser medium means refractive index is higher. Tell me air and kerosene में which is denser, which is rarer? बोलो शोभा. Which is denser, which is rarer? Air and kerosene में. By seeing refractive index, tell me.
Kerosene.
Kerosene is denser medium because refractive index is higher, and air is rarer medium, refractive index is lower. Okay. Abhiram bolo. Ruby and diamond, which is denser, which is rarer medium?
Diamond is denser.
Denser because refractive index is more higher and compared to ruby. Okay, see, it depends on medium to medium. Suppose now ruby is rarer हो गया, बाद में if I combine rock salt and ruby में, this will become denser हो जाएगा. So comparison में denser rarer बोलने का. Okay, ऐसा नहीं कि कभी भी वो ये denser ऐसा नहीं रहेगा. Okay, but सबसे ज्यादा rarer will be air. Air के comparison में all are become denser only. Understanding? तो उसका definitions भी लिखेंगे. तो लिखो optically denser medium means the medium with high refractive index is called optical denser medium, and optically rarer medium is medium with lower refractive index is called as optically rarer medium. So refractive index किधर से आया? Snell's law से आया. उसके बारे में we are talking. Every material has their own refractive index. Based on that only we should say rarer कौन सा है, denser कौन सा है बोल के.
Sir, in exam they will give the refractive index of the material.
Materials they'll give.
Okay.
So no need of by hearting anything. Okay, हो गया. Okay. Okay. We will now. I told you when a light. I told you when a light is passing from one medium to other medium, it bends. It bends towards normal or away from normal. We will see which is towards, which is away from normal. Okay. So लिखो condition क्या है? When a light enters obliquely from rarer to denser, it bends towards normal. When it ends from rarer to denser. Okay. देखो rarer to denser, when it's entering, it bends towards normal. मतलब मीनिंग क्या होगा? एंगल आई ज्यादा है और आर ज्यादा है, विच इज एंगल आई इज greater than angle R, or I can write as angle R is less than angle I. Right? Yeah, so when entering from rarer to denser, it bends towards normal. Towards normal. How to prove that one? This one proof. How to prove that angle R is less than angle I, or angle I is greater than angle R?
Sir, should we draw a diagram as well?
Yeah, diagram ड्रॉ कर लो. But proof मालूम है किसी को? How to prove? एक्सपेरिमेंटल दिख रहा है आपको, ठीक है?
Sir, prove what?
How the angle I and angle R is greater बोल के कैसे पता चलेगा? When the ray is entering from rarer to denser.
If it bends towards the normal or away from normal?
Away from normal. हाँ. एक्सपेरिमेंट दिख रहा है आपको, लेजर लाइट डालने से पेंड हो रहे हैं. ओके, बट मैथमेटिकली और फिजिकल मतलब फिजिक्स यूज करके कैसे करेंगे? एक रिफ्रैक्टिव इंडेक्स किस लॉ से आया? रिफ्रैक्टिव इंडेक्स केम फ्रॉम विच लॉ? स्नेल्स लॉ. वही यूज करने का. सो देखो, साइन आई by sin r is constant, that is equal to refractive index n21, that is equal to n2 by n1, right? Okay, you tell me n2 बड़ा है और n1 बड़ा है. Tell me किसका refractive index is more when it's entering from rarer to denser? किसका refractive index is more? n2 or
medium.
denser medium. मतलब n2 is greater, right? When
Yes.
when you divide with this bigger by smaller, the value will be greater than 1 or less than 1?
Greater than.
Greater than 1, right? Okay. So क्या होगा? Sin I, if you cross multiply, 1 into sin R is greater than sin R. Sin cancel. Angle I is greater than angle R. We proved. Angle I is greater than angle R. By using Snell's law. Simple. समझ में आ रहा है? Now same way try करो. When a ray of light is passing from denser to rarer, क्या होगा? It bends away ना towards
Away.
away from normal. Prove करो. Diagram draw करके prove करो by using Snell's law. Same method में. एक copy दा. So same way prove करो for the second one. देखो, when light enters obliquely from denser to rarer, it bends away from normal. ऐसा bend away हो जाएगा. That means angle R is greater than angle I, or angle I is less than angle R. By using Snell's law, prove करो. सो कैसे प्रूव करेगा? साइन आई बाई साइन आर is equal to n to 1, which is nothing but n2 by n1. Now second medium is rarer medium, this is denser medium. मतलब second by 1 if you do, it is less than 1. When you divide, it is less than 1, right? So multiply sin I is sin r into 1 is less than sin r. So sin sin cancel, angle I is less than angle r, which we put. So right. सो एग्जाम में यही पूछेगा आपको, डेंसर टू रेयर तो क्या होगा, रेयर टू डेंसर रे तो क्या होगा. ओके, समटाइम्स दे विल गिव सिंपली डायग्राम आल्सो. Simply this diagram they will give like this angle, and like this angle. So by seeing this one, you should say this is rarer, this is denser बोल के, और denser rarer बोल के आपको आइडिया आने का based on the bending phenomenon के हिसाब से. अभी देखो अवे है तो we can say this is rarer medium, this is denser medium, ऐसा. Towards है तो denser rarer बोल के आएगा. So way of asking questions will be different way. Concept understand करो. Understood? Clear? Yes. So कब बेटा सब लोग? तो इसका न्यूमेरिकल्स करने वाला है बेस्ड ऑन द रिफ्रैक्टिव इंडेक्स का. सिंपल है. सी रिफ्रैक्टिव इंडेक्स आपको ऐसा लगेगा बड़ा है, कुछ नहीं है. वेरी स्मॉल डेफिनेशन, 2 मार्क क्वेश्चन से ज्यादा नहीं पूछने वाले मेन एग्जाम आल्सो. व्हाट डिफाइन रिफ्रैक्टिव इंडेक्स मींस स्नेल्स लॉ का लिखने का. एंड एक न्यूमेरिकल आएगा, सिंपली फॉर्मूला बेस्ड ऑन n21 इज इक्वल टू n2 by n1 और c by b और v1 v2 यूज करेंगे. ओके चलो एक क्वेश्चन करो. लाइट एंटर्स फ्रॉम air to glass plate having refractive index is 1.5. मतलब किसका refractive index is दिया है? Which refractive index is given to you? When the light enters from air to glass having refractive index is 1.5. ये 1.5 किसका refractive index है? Air या glass?
It's glass with respect to air.
Air, glass with respect to air. Because air का refractive index you already know 1. 1 is the air का refractive index. So refractive index of glass with respect to air. मतलब n21 is given to you. That is 1.5. Okay. What is the speed of light in glass? So I am calling of Vg is how much? And air का मालूम है ना 3 × 10⁸. So which formula will use? Absolute refractive index का formula will use. खत्म हो जाएगा. So what is the formula? n21 is equal to c by v. Right? First is air only. Second is any medium. Glass होने दो, कुछ भी होने दो. इधर glass है. मतलब इधर Vg लगा रहा हूँ. Substitute n21 के जगह में 1.5 is equal to ये कितना है? 3 × 10⁸ upon v. V is nothing but speed of light in that glass only. Okay. Now fine.
So 2 into 10 power 8.
Yes, good. 2 × 10⁸. आया किसको? So n21 value is given, मतलब glass with respect to air only given. This is nothing but n21, right? That उसके जगह में substitute 1.5. C value already know air में 3 × 10⁸. If they don't give also, you should buy air का 3 × 10⁸. By the speed of light in that glass. So if you know the refractive index, if I know the speed of light in air, I can find the speed of light in that glass medium में. आया सब लोग को? सब on the video? जाना भी on the video? सब लोग आने ऑफ किया तो क्या बैठेगा यार? भूख लग रहा है सब लोग को? ओके हाँ हो गया. अभिराम हो गया?
No, sir,
got
absolutely.
आंसर?
Yes, sir.
नेक्स्ट करो. refractive index of water is 4/3 is given, and glass ka refractive index 3/2 is given. What is the refractive index of glass with respect to water I want? So always try to write refractive index of water they given, right? So we represent as refractive index of water, W is equal to 4/3. And refractive index of glass they given. Refractive index of glass, how much they given? 3/2. He is telling refractive index of glass with respect to water. Glass with respect to water, NGW is how much? Well, N21 ka formula only. Since he is not talking about speed here, no need of using the speed ka concept. Only N2/N1 formula use करेंगे.
Sir, 9/8.
हाँ आया नादिया 9/2.
Yes, sir.
हाँ, so इसका फॉर्मूला क्या है? NG/NW. Right? N21 means N2/N1 ऐसे ही. NG value is how much? 3/2 by NW value is 4/3. और रेसिप्रोकल किया तो it is 9/8. खत्म. This is a refractive index. And what is the units of refractive index? Anybody? SI units of refractive index. N21 formula मालूम है ना? N2/N1 is equal to V1/V2 is equal to C/V. This is the formula, right? Tell me, what is the SI units of refractive index?
meter per second.
Okay. Anybody?
So no unit.
Huh?
No unit.
Very good, very good. No units. See, speed ka units are meters per second. Either be meters per second. Cancel. No units. So refractive index has no units. They wantedly ask exam में, what is the units? Some people will write meters per second. Okay, we should not write meters per second. There should be no units बोल के लिखने का. Okay, understood? So इधर तक वो refractive